now let's talk about the third atomic particle. So the third one we're going to talk about, what's left, electrons. Now here we have fluorine, and fluorine, again, atomic number 9. How many protons does it have? Well, definitely you can count them. There are also 9. Now here we're showing fluorine with 9 electrons, but typically when you have a fluorine in like the human body, if you introduce it to the human body, well, what typically happens is that fluorine will tend to take on an additional electron. And this is, if you want more details about this, then you should read more about valence shells. But what I'm getting at here is that sometimes you can have unequal numbers of protons and electrons. In all the atoms in your body, each atom is not going to have an equal amount of protons and electrons. Sometimes you have something called an ion. So an ion, by definition, is an atom where the number of protons is not equal to the number of electrons. And you have many types of ions in your body, including the electrolytes. So in this example of an ion, what do we have? Well, we have 9 protons and 10 electrons. Now, the thing is that, remember in the previous slides I said that protons have a positive 1 charge, electrons have a negative 1 charge. So what's the overall charge of this fluorine ion? Well, what you do is take 9 times positive 1, which is 9, and then take 10 times negative 1, which is negative 10. Add the two together, and what do you get? All right, let's ask the chat. So if you have 9 minus 10, what do you get? What's the answer? What's the charge of this fluorine ion that took on an additional electron? Yep, looks like everyone's saying negative 1, and you're all correct. So that sign is very important. It's not positive 1. So the charge isn't just 1. You need that negative sign because this fluorine ion is overall negative. So it's a negative 1 charge. Now here we have sodium. So sodium, atomic number 11, therefore 11 protons. But say we lose an electron over here. So what's the new charge of this sodium ion? So we have 11 protons. Protons have a positive 1 charge. Electrons have a negative 1 charge. What is the overall charge on the sodium ion? Well, 11 minus 10, it would be plus 1. That would be the charge of this sodium. So sometimes you also see that whenever you have this number up here in the upper right corner, that refers to the overall charge of that particle or atom. If there's no charge, it's not going to, sometimes they use a 0, but if it's an ion, it's going to show you a plus or negative some number, because again, it would have to have some sort of unequal balance between protons and electrons. Great, so it seems like people get it. All right, so here we have a hydrogen atom, but now, so here in this original state, we're showing a proton, electron, so there's no charge. But thing is that with hydrogen in the body, what happens is that it tends to lose the electron, and it has a plus 1 charge, right? So no proton, 1 minus 0 is 1. Thing is that in the universe, 99.9% of hydrogen has no neutron. So if you have a hydrogen ion and it has no neutron, what do you have? You only have a proton. So this is why you might see like hydrogen ions is equal to H plus, is equal to, sometimes they refer to hydrogen ions as simply protons. And why is that? Well, by definition, if it's an ion, it's not going to have an equal amount of electrons, and it's positive 1, so it's not going to have an electron. And most hydrogen in our universe doesn't have a neutron. So what are you left with? Just a bare naked proton. So this is what we have with a hydrogen atom. Or not hydrogen atom. A specific hydrogen atom called a hydrogen ion, also known as H plus in abbreviation, also known as a proton. Okay, so then molecules and compounds. So these definitions, so a chemical bond. So when I think of like chemical bonds, the way I like to think of chemical bonds is like when you're forming a bond with someone, you're forming a relationship, right? And it doesn't have to be a romantic relationship. You can have relationships with your friends, you can bond with friends, you can have relationships with family, you can bond with family. So here's so chemical bonds are pretty much relationships between atoms. So there's some sort of attraction or bond between these atoms, and then molecules. So when molecule refers to when you have multiple atoms that are bonded together. So these are atoms in a relationship. Now an element, so atomic elements referring to the number of protons. So if all the atoms have in a molecule have only one type of atomic element, it's still an element. Now a compound, this is when you have any sort of mix, at least two different atoms bonded together. This is a molecule with at least more than one type of element. So it doesn't matter if it has like 2, 3, 4, a dozen different atoms, different elements bound together. As long as it's not a pure element, it will be a compound, for at least for a molecule. So then when you see a chemical formula of something, it lists how much of each element is in the molecule. So here we have all these molecules over here, and if you're going to write out the chemical formula of all of these, you're going to see notation like this. So this number here in the lower right, that refers to the number of atoms found in that compound or molecule or element. So these are all elements over here, but see that in this hydrogen gas particle right here, you have 2 hydrogens, and here we have oxygen gas, and we have ozone over here. So notice that there are 3 oxygens here, and there are 2 oxygens here. And these are all compounds we see over here. So what we have are multiple types of atoms, and then they're all chemically linked together. This is still an element because it's a pure type. And even if it has an ionic charge, this over here is still an element because even though it has a different charge on this atom, both of these are still oxygen molecules. But again, if it only has one type of atom, it's an element. If it has multiple types, it's a compound.